Alright then, welcome back. Here we are, our final lesson in Unit 3. This is Unit 3-6. You can barely see it on there. A little different format on the slides, and so they kind of faded out that title for you. But nonetheless, this is called Special Factors. Now really it's going to be kind of a rehash of what you already know, things we talked about before, which you're going to see in just a second here. Oh, wait a minute. Here's a new math career for you, and lo and behold, look at that, math teacher. I wonder who does that every day. You can see the salary isn't quite what the chemical guys get or even the geographer, but that's okay. We like what we do. You kind of recognize what a math teacher does all the time anyway. And you can see the math that we have fun down here doing. Every bit of it is a super joy to get through. And I remember lots and lots of taking those classes, especially that number theory. It was so much fun. All right, so do you remember these two? Well, maybe you remember that image there. Maybe evil twins. Does that sound familiar to you? A plus B times the quantity A minus B. And that would yield you with A squared minus B squared. Remember, that's a difference of perfect squares. Isn't A squared A times A and B squared B times B? So, and difference, of course, in math means to subtract. So difference of squares. And how about perfect square trinomials? Remember this old friend? A plus B quantity squared, and this becomes, of course, A squared plus 2AB plus B squared. This is the form that we remembered, and we try to remember. We go ahead and square the first, write it down. Square the second, write it down. Multiply these two guys by themselves and times 2. So, how about this one? Maybe you jot this one down in your notes real fast and see if you can get it just by following this form right here. So if you take a look at that form, okay? What do you think? How about x squared? Well, that's x times x. How about 2 squared? That's 2 times 2, because those are the first two terms here, x and 2. And then how about 2 times x times 2 out in front? Remember that 2 by 2 box? Didn't we used to add things diagonally, right, whenever we use it? So that means 2 of those put together. Now just simplify this. X squared, positive 4, and of course 4x, and there's your answer. X squared plus 4x plus 4. And many of you by now can just do that just by following the pattern. Okay. Now if you can identify either of these, the evil twins, difference of squares, or PST, the perfect square trinomial, your math life gets much, much easier. So, your turn here. Identify the following as evil twins, PST, or neither. PST, of course, is perfect square trinomial. So what do you think about that one? X squared plus 4x plus 4. I'll give you a few seconds to think about it. Is that evil twins or a perfect square trinomial or neither? Well, that's a perfect square trinomial. Perfect square trinomial. You'll notice that 4 is a perfect square and positive 4 is a perfect square. How about this one? B squared minus 25. What do you think about that guy? No middle sister, so we're looking at evil twins. How about this one? 16c squared minus 9. Look carefully here. Is 16 a perfect square? Sure is. Is c squared a perfect square? C times c. And is 9 a perfect square? The answer is yes. And is it a difference of terms? That's correct. It is evil twins. How about this one? A squared plus 3a plus 5. Well, let's see. We have a trinomial, so maybe evil twins is out of the picture, right? So either it's perfect square trinomial or neither. Is 3 a perfect square? Is 5 a perfect square? Well, the answer to that is no. So that's a neither. It's neither one of those. It's just a regular old run-of-the-mill trinomial. How about this one? C squared plus 2c plus 1. What you're really focusing on here, I know I asked you about the 3. Really, we should look here at the 5. Look here at the 2. We know 2 is a prime number. What about our 1 here? That is a perfect square trinomial. 1 times 1 is 1. 1 plus 1 is 2. Okay. How about this one? 4x squared minus 20. Looks like a binomial. I see subtraction. I see a perfect square in 4. I see a perfect square in x squared. Is 20 a perfect square? Don't say 10 times 10. Is 20 a perfect square? The answer is no, so it's neither. Okay? 20 is not a perfect square. How about this one? N squared plus 8n plus 16. Could you, I think we know this is not going to be evil twins, is 16 a perfect square? Well, isn't it 4 times 4? And is 4 times 2 that number there? Correct answer is PST, perfect square trinomial. How about this one? 25n squared plus 64. Looks like a binomial, so it's not going to be a perfect square trinomial, obviously, because it's a binomial. There's two terms. 25 is a perfect square. n squared is a perfect square, and hey, 64 is a perfect square also. But why am I not going to write down evil twins? If you put down evil twins, what's high school teacher going to say to you? What did we miss? Well, is this a difference of squares? And the answer is no, it's not. So we can't say that. It's neither one. Okay? It's not going to be a perfect square trinomial or difference of squares or evil twins. How about this one? M squared plus 24m plus 144. Is m squared a perfect square? Sure is. Is 144 a perfect square? Yes. If you take the square root of 144, that's 12, times it by 2, do you get 24? Correct answer is indeed PST. So that's it for Unit 3-6. There's your lesson, 8.5 there, and video examples 1, 2, and 3. Okay? So please make sure you have a question there for us tomorrow or when we see you again. All right then, we'll talk to you soon.